Good morning, everyone. We are joining together today to explore the many aspects of fire safety and preparedness. We will dig into the details of firefighting, such as breathing apparatus, mobile firefighting equipment, rescue, containment, judgment, tools and equipment, and more. Let's get started. This program focuses on the practical aspects of being a fire brigade member, including breathing apparatus, mobile firefighting equipment, hose handling, and rescue. Participants will learn exposure, containment and understanding of fire behavior, and develop skills in firefighting strategy, tools and equipment, judgment, speed, and teamwork. We will now begin to actually practice these skills. Having knowledge of fire behavior and strategy, the ability to handle tools and equipment skillfully, having good judgment of fire conditions, and the capacity to work as a team are the four main elements of firemanship. For successful containment and extinguishment of a fire, as well as to save lives, all of these elements must be combined. Knowledge of fire behavior and strategy provides important understanding about how a fire spreads and how best to contain and extinguish it. Skill in handling tools and equipment is crucial for ensuring the correct tools are used effectively. Judgment of fire conditions is vital in making the most suitable decisions about how to tackle the fire. Finally, quick attack and control and teamwork are both essential to make sure the fire is contained and put out quickly and safely. At our firefighting program, we provide firefighters with the knowledge and training needed to do their jobs safely and effectively. We understand the risks and safety hazards associated with firefighting and believe that the best way to reduce these is through education and proper training. Our program offers comprehensive instruction in fire safety, firefighting techniques, and emergency first aid. We also provide specialized courses to those wanting to further their skill sets. Through our program, firefighters can be sure of getting the best training needed to protect their communities. Fire is an intricate occurrence that is defined as the swift oxidation of a fuel source with the generation of heat and light. Combustion, nevertheless, is the consequence of a chemical reaction that is autonomous, forming energy or extra chemical reactions for the same intent. For firefighters to be successful in combating any accident involving these processes, they must comprehend the nature of fire and combustion. The fire tetrahedron is a prevalent idea in fire science, which consists of four components to initiate combustion: heat, chain reaction, fuel and oxygen. Heat is the energy that sets off the chemical reaction, with chain reaction being the chemical reaction when sufficient heat has been brought to ignite the fuel. Fuel is any material that can burn in the presence of oxygen, while oxygen is the force behind the burning, as it is mandatory for the fuel to catch fire. Combustion will not be possible without any of these four components. Oxidizing agents, like oxygen, are substances that give off oxygen or other oxidizing gases during a chemical reaction. On the other hand, fuels are substances that are oxidized or burned when ignited. It is essential to be conscious of the hazards that oxidizing agents and fuels can bring during firefighting operations. Heat is a necessary part of fire and is essential to start a fire. Heat energy from a spark or flame mixes with the fuel to cause a fire. It's important to understand how heat energy intensifies a fire and can cause it to spread quickly in order to prevent and control it. Heat plays a vital role in our everyday lives. It can be generated in a wide range of ways, including chemical, electrical, mechanical, and nuclear power. Having an understanding of the main sources of heat is necessary in order to know how to effectively use and manage it. Understanding the differences between solid, liquid, and gaseous fuels can be important for fire safety. Solid fuels, such as coal and wood, are those which are solid at room temperature. Liquid fuels, such as gasoline and diesel, are those which are liquid at room temperature. Gaseous fuels, such as propane and natural gas, are those which are gaseous at room temperature. Being familiar with these three types of fuels is essential when dealing with fires and fuel sources. Understanding the principles of solid fuel use is essential when managing it. At a particular temperature, solid fuels will give off combustible vapor. Additionally, their positioning can impact how they burn. By keeping these two components in mind, you can be sure to manage the use of solid fuel effectively and safely. Gaseous fuels are highly flammable and pose serious risks if not handled correctly. As they are already in an ignitable vapor form, firefighters must be aware of the dangers associated with them, such as the spread of toxic chemicals, a risk of explosions and the possibility of flash fires. Knowing the suitable methods for controlling and putting out fires involving gaseous fuels is a necessity. Flammable liquids can vary in their oxygen content, falling anywhere between too lean and too rich. Each liquid has an upper and lower flammability limit, meaning that it can only ignite and sustain combustion within a certain range of oxygen content. It is essential to know these limits in order to assess the hazards associated with certain flammable liquids and pick the necessary safety precautions. For this slide, the voiceover script would be: at temperatures below the flash point, the vapor produced by a liquid fuel is insufficient to be ignited. However, when the temperature reaches the flash point, the vapor may be ignited momentarily by a flame. At the fire point, a liquid fuel gives off sufficient vapor to support continuous combustion. Knowing these temperatures is important for firefighters to safely and effectively combat fires. The auto-ignition temperature of a liquid is the minimum temperature that the liquid will ignite without the presence of a pilot flame or spark. Flammability limits are used to determine when a flammable gas or vapor is present in the atmosphere and whether it may explode. The lower and upper flammable or explosive limits will specify the range in which an explosion can occur. It is important to understand these limits to ensure the safety of personnel and equipment in any given environment. To sustain combustion, the balance of fuel, oxygen, and heat must be carefully managed. As more fuel is burned, the temperature of the fire increases, which can result in the production of smoke. This smoke can cause further problems such as poor visibility, which can hamper firefighter efforts. Fire brigade members must be equipped to manage any eventuality that they can face during their work. They need to be able to enact the suitable actions and strategies promptly and accurately. Having the proper preparation and experience is fundamental to manage any possible emergency effectively. Class B fires are composed of flammable and combustible liquids and gases, such as oils, motor spirit, and paints. Utilizing a dry chemical foam or carbon dioxide extinguisher is the safest way to extinguish such a fire. Never use water. Firefighters must be extra cautious when dealing with Class C fires. These fires involve energized electrical equipment and require non-conductive, insulated tools to fight. They can spread rapidly, and it is essential that firefighters are well versed in fire extinguishing strategies in order to act swiftly. It is important to be aware of Class D fires as they involve combustible metals such as lithium, sodium, aluminum, magnesium, and potassium, which burn at much higher temperatures. Metal fires should be smothered, not extinguished with water, and can easily reignite even after they seem to be snuffed out. Consequently, caution is essential, and it is paramount to have the correct extinguishers on hand for dealing with Class D fires. Class K fires are particularly hazardous and hard to put out. They can break out in commercial kitchens, where unsaturated cooking oils are heated in well-sealed appliances. In contrast to other fire classes, they require unique approaches to be extinguished and can leave behind a tacky, still burning residue that can cause a new ignition. For this reason, firefighters need to have the vital equipment, techniques, and understanding to fight Class K fires adequately. When we look at the four elements of firefighting, one of the most important aspects is removing heat. If we can reduce the heat, the other components of fire, namely the fuel, oxygen, and chemical chain reaction, are removed or inhibited. This is how we use the element of oxygen to our advantage in putting out a fire. We can reduce the available oxygen, while increasing the heat, to put out the fire. Quenching and cooling is an essential technique used in firefighting as a way to reduce the heat of the fuel and prevent the chain reaction from continuing. It involves lowering the temperature of the fuel source to a non-combustible level, thereby eliminating the potential to further ignite or spread the fire. Quenching and cooling can be employed on various sizes of fires to help reduce damage and save lives, and it is essential to understand the proper methods of doing so. Fuel removal is an essential element of firefighting. It can entail cutting off the supply of liquid or gaseous fuel or extricating solid fuel to break the chain reaction and stop the fire from spreading. Firefighting personnel must be familiar with and comprehend these techniques. Different fire extinguishing agents can be used to put out a fire. Water, foam, carbon dioxide, dry chemicals like Phylix and FM200, and wet chemicals like hydrocarbons all are effective in different scenarios. Depending on the size and class of fire, certain agents may be more appropriate. It is important to be familiar with all available agents and know how to best utilize them. When using breathing apparatus, establishing a proper seal between the mask and the face is essential and should be done with attention to detail and safety. Before entering a hazardous area, fire brigade members should also determine the level of air supply present. It is essential to ensure that a solid seal with an effective airflow is in place in order to use breathing apparatus effectively. Class BC powder consists of sodium bicarbonates, more commonly known as baking soda, and potassium bicarbonates, commonly referred to as purple K. Additionally, potassium carbonate, or Monex, is also classified as Class BC powder. Moving on, Class D involves metals, such as ternary eutectic chloride and Flarex, a complex compound. Carbon dioxide can be used effectively to put out fires due to its ability to reduce the oxygen concentration in the burning area to below the lower flammable limit. It is especially suited for the task as it is not reactive to most substances, and comes out as a gas which can spread out throughout the fire area. In addition, it generates its own pressure for discharge and is also non-conductive of electricity, making it suitable for extinguishing Class C fires. Foam extinguishment is carried out by using a triangle composed of three main components. These include water content, which works to cool and smother the fuel, the blanket effect, which forms a protective floating blanket on the liquid surface, and the formation of bubbles, which prevents the creation of combustible mixtures of vapor and air. Together, these elements help ensure the successful extinguishment of foam. Conduction is the process of transferring heat energy through molecules colliding with each other. When a material is heated, the molecules within the material expand and transmit the heat energy to its neighboring molecules, in turn eventually transferring the heat energy to the entire material. This is why baked goods, like cakes, usually cook from the inside out. Understanding how conduction works is important for firefighters as it allows them to combat fires in its early stages, thus helping protect lives and property. Convection is the transfer of heat energy in fluids, such as liquids and gases. When a fluid becomes heated, it expands and becomes less dense. This causes it to become buoyant and rise in the cooler areas surrounding it. As it rises, cooler and denser fluid takes its place, resulting in a circular motion of heated fluid. This continuous motion is known as convection, and is an effective means for transferring heat energy from one place to another. Radiation is the process of energy transfer by electromagnetic waves. It is an invisible form of energy that can travel through space as well as through matter. Radiation can be used for a variety of purposes including heat transfer, imaging, and communication. Radiation can also be hazardous, and it is important to take appropriate safety measures when working with or near radiation sources. Combustion is the process of a chemical reaction between an oxidizing agent, usually oxygen, and a fuel, usually a hydrocarbon. This reaction typically releases heat, light, and may also produce smoke. The rate of combustion is determined by the chemical characteristics of the fuel used and can range from slow to fast. It is important to have an understanding of the fuel properties to maintain fire safety, as having the right knowledge and utilizing the right strategies and equipment can help to effectively control and contain combustion. Combustion is initiated with the joining of heat, light, air, and fuel. The heat causes the fuel to separate into little pieces which then meet with the oxygen in the air to form vapor. In the presence of adequate heat, these fragments break down further to shape combustible vapor that can catch fire and begin burning. This convergence of heat, light, air, and fuel is the bedrock of all combustion processes. Fire is a serious hazard and must be taken seriously. Understanding fire's different stages of development is key in battling it. The first stage is the incipient stage, when the fire has just started and is in its early development. After that is the flashover stage, where the temperature of the fire has risen enough that any fuel that was not already burning can now ignite. After flashover is the growth stage, where the fire is growing, consuming more oxygen and producing more heat and smoke. Finally, the fully developed stage is when the fire has reached its maximum size and can start to spread. With appropriate action, the fire can then be put out and enter the burnout phase. Confined space fires can have serious and unpredictable consequences. The fire tetrahedron is a concept designed to help professionals understand fire behavior. It consists of four main components: heat, fuel, oxygen, and chemical chain reaction, all of which must be present for combustion to begin. When these conditions are met, the fire enters the ignition stage, followed by the growth stage in which a fire plume forms. Next comes the flashover, marking the transition between the growth and fully developed stages of fire. At this point, all the combustible materials in the space are burning in the fully developed stage. Finally, the fire enters the last stage, decay, where the rate of heat release gradually slows down. It is vital to gain an understanding of the fire tetrahedron in its stages to ensure the safe prevention and handling of confined space fires. SCBA is the most important tool in a firefighter's toolbox, giving them the ability to safely enter hazardous environments and carry out their duties without fear of health risks. Not only does SCBA enable them to move around freely in a smoke-filled or hazardous atmosphere, but it also prevents them from coming into contact with any hindering fumes or gases, thus ensuring their safety while they are working. SCBA is truly a life-saving tool that permits firefighters to complete their job with confidence and efficiency. Self-contained breathing apparatus, or SCBA, is an essential piece of equipment for firefighters. It is composed of several elements. The cylinder, for instance, contains the supply of air. Additionally, the backpack carries the cylinder and the other components. Furthermore, the low-pressure warning device alerts the user when the air pressure drops. Additionally, the lung demand valve, or LDV, modulates the rate and quantity of air when inhaling and exhaling. Lastly, the full face mask fits snugly and guards the user from smoke and hazardous gases. These components, combined, form a complete SCBA. The lung demand valve, LDV, is a life-saving device that provides a steady and regulated supply of air to fire brigade members in a smoke-filled environment, so as to ensure their breathing is not impaired when fighting a fire. It is vital to be knowledgeable about the operation of the LDV and the right methods of use. It is also essential to practice regularly, to be able to carry out this important task in a safe and efficient way. When it comes to firefighting, face masks are essential pieces of equipment. They help protect against airborne particulate matter and toxins, making it easier to work more efficiently and with more assurance. To make the most of your face mask, ensure that it fits properly and is secured in place correctly. The mask should form a tight seal around the nose and mouth. Moreover, it is important to ensure the maintenance of your face mask to guarantee that it works optimally. Ensuring that a self-contained breathing apparatus, SCBA, is compatible and ready to use is the first step before donning the equipment. Putting on the SCBA includes wearing the face mask, harness, belt and cylinder, and ensuring that everything is securely attached. After the SCBA is on, the user can proceed with any tasks. When the tasks are finished, the user should doff the SCBA by following the same steps as when putting it on, but in reverse.